Okay, I wanted to talk about these little rubber stoppers. Now, back when I started this project, I made these little rubber things. Now, if you remember, I said they were made out of 1/16 rubber, and it was a 1/4 inch diameter. And I used a punch that was for putting holes in leather. And I punched these out of a sheet. And then I had to put these 1/4 inch counterbores in here. There was no hole in the center. They were just a 1/4 inch end mill that went down about 45 thousandths. Then they were epoxied into that hole. Now that's what I have now in my unit. It looked like this. Now, I was always, well, these pieces I just made. Okay, that'd be this piece and this piece. This is the back jaw. This is the front jaw. But, ever since I made these parts, these, I always wondered about them coming out. And I thought about making some kind of retainer plate to hold those in there. Because all I had was, I put some epoxy in there, but you could put some contact cement or whatever. But, I was always how, when you press something against a piece of rubber, sometimes it sticks to the item you're pressing against. And if it's pressing against the circular piece, it might come out. And I didn't want to put any kind of oil or anything on here because then it'll start slipping. And then it'll kind of defeats the purpose. But, at different times I thought about, well, maybe I could put a hole through there and put some kind of pin in there, some kind of retaining pin or whatever. But I never could really come up with a good idea because it's already so small. So I went on eBay. Well, what happened was I saw these, like on a door, they got these stoppers. You push them into a door jamb, and it stops the door from banging the frame. So I thought, well, maybe there's something out there that I could get that'll work. So I went on eBay, and I looked at some stuff, and it wasn't too long ago they had these. They got a lot of different rubber products, but they had these ones with it had a angle on the front where you pull it through a hole. Then it had a diameter that fit into a hole, and then it had a head diameter. And I thought, well, that's just what I'm looking for. So anyway, what it looks like is that it's got a 1/4 inch head diameter. It's got a 3/32 from here to there, 1/8 hole diameter, and it's 3/32 thickness, and then it's got a 3/16 on this side, so you could pull it through a hole, and then this will lock into the hole, and that way it won't come out. And I thought, well, that's a great idea. You know, that's just what I'm looking for. So I ordered them, and then I made these parts because my unit, you know, it's being used right now at work, and I don't want to tear it down because I'm running a job on it. But I thought, well, if I could make some parts and see, you know, I didn't want to tear the unit apart and then modify the parts and find out it didn't work, because then the unit would be down, and then I'd have to make the parts again. So I thought, well, let me make another set of parts with to fit these pieces, and that way the unit's still operating, and if these work, then I just change it out. So that's what I did. I made another set of parts, and the original went down 45 thousandths, like I said, with the 250 diameter. So all I would really have to do is put a hole through it, a 1/8 or bigger, probably about 1/28 diameter or somewhere around there. You know, you want a little bit of a looseness, but you don't want it falling through, but you don't want it really tight either. So that's what I did. I made these, and I put a 1/28 diameter through there, and I went down the original 45. Then on the back side, I took a 3/16 end mill, and I went down this 1/4 inch plate. So I went down till I got the 3/32, and so this is about what I did. The original one is like 50 thousandths deep. It's 1/4 inch. I got a 90 thousandths land in here, and then whatever this turned out to be happened to be 110 with a 3/16 diameter. So that's what I did. I made this part, and I couldn't get the plug in it. You know, no matter how hard I tried, I couldn't get that plug in there because of this 3/16 diameter was just too big. It wouldn't let me pull it, stretch it enough to get it in the hole. So what I did was I held this in a pair of pliers, kind of like this here. And I took a razor blade and I just skimmed one side. A knife doesn't work, you have to use a razor blade. But I skimmed one side, and I flipped it over, and I skimmed the other side. Now you're not cutting this piece here, you're just cutting that angle piece. So what you have is you have the round part with basically two flats on it. I don't know if you can see that. So what you're doing is the only 3/16 is on one half of it, and then 180 degrees is the other 3/16. So what you're doing is you're making this easier to fit into something because you're reducing over half the material. But these two areas where you didn't cut, you still have the 3/16 diameter, and that'll hold it in place. So that's what I did, and it worked out good on one. So I said, well, yeah, it worked out good. I got it in there. So then I cut the rest of them because I need 10. 5 for this part, and then 5 for this part. 1, 2, 3, 4, 5. So I got this one in. And what I did back here was I did the same thing. This is down 45 thousandths. Then I went down here with a 3/16, and I made that so there's about a 90 thousandths land between the front and the back. And then this in here, that's just clearance. Used a 1/4 inch end mill, came in there, and because you have to have room to get your pliers in there to pull that guy through. So that gives you plenty of room. I mean, you could bring that back, as far as you want. But I didn't see any need in it. I just need to bring it back far enough to get the pliers on it to pull it through. So that's what I did. And as far as the surface sticking up, I mean, you got about, well, it says 90 thousandths sticking up, and you got 45. But the little dome on top, I mean, is where this piece, the original piece, was 1/4 inch, and it was all circular, as in one thickness. This is domed. So when this brake first engages, there's very little area for that to hit on. So that's going to compress even more. And as you go further down, it's going to increase the pressure because now you're getting into a bigger area. As you go down, the point of it is not much. It's going to compress easily, but as you go down further, you're getting into a bigger diameter, so it's going to take more force to compress. So it's obviously sticking up quite a bit further than that one. But as far as the pressure to compress it is about the same. I think the end result is going to be the same, because this original one, you're going to go down maybe 5 thousandths. I don't think you're going to go 10. But this one here, I mean, when you first push it down, it's going to go down 10, almost 15, but you're going to end up with the same result. You're not going to hit the aluminum piece. Yeah, the original piece was made out of Delrin, and I decided to go ahead and make this out of aluminum. But what I did was I cut all these, and I'm going to install them in here. And then when I get a chance, I'm going to take the other ones off the machine and exchange them for these parts, because I don't want these parts coming out. So being how they're captured with this hole, I think it'll It's one less thing to go wrong. So that's what I'm thinking. But we'll give it a shot and see what it does. All right. Yeah, I made the aluminum front piece, the aluminum back piece. I made aluminum mounting plate too, so that they all fit together. The other ones, like I said, were Delrin. All right, talk to you later. So we got to a stopping point. So I took this thing off, took it apart, changed out the old parts for the new parts. Now these are the old parts. Now you can see I was missing some of those circular things. I have 2 on there, and I'm missing 3. Now the outside piece, they were all on there, but the inside piece, I got 1 here, 1 there, and I was missing 3. The unit was still working with just 2 there, but what happens is it puts it in a bind because one side's pulling further than the other side. So anyway, with the new unit installed, now you can see where I had to pull these little pieces through. This doesn't hurt anything at all. They're just out in space. So we're anxious to see how this is going to work out. I'm sure it'll work out a whole lot better. But so I'm glad I took that apart. Glad I was able to change those out. Put in new parts. So that's going to work out really good.